The previous video discussed finding conversion units within the metric system. And they're all based on the power of 10, so they're pretty easy to find once you get the hang of King Henry died by drinking chocolate milk. We're now going to use a way of converting called dimensional analysis, and this is not the same thing as you've used before. However, this dimensional analysis skill will carry you through many chapters in chemistry. So even if you think you know a better or more simple way to do this, trust me when I say you do need to know how to do this. This is what an example of one of the easier problems would look like. For instance, how many inches are in 2.85 centimeters? Well, the first thing you're going to want to do is find out either how many inches are in a centimeter or how many centimeters are in an inch. And it doesn't really matter which direction you go with this because it's an equivalent statement. It doesn't matter if you say 1 inch equals 2.54 centimeters or 2.54 centimeters equals 1 inch. It's an equivalent statement. Equivalent statement. And there's two different ways we could write an equivalent statement. We could write it as 1 inch has 2.54 centimeters, or I could say 2.54 centimeters contains 1 inch. Either way, it is just fine. As long as whatever's in the numerator is the same thing as what's in the denominator, you have an equivalent statement. And these equivalent statements will carry you through dimensional analysis. This is one of those English to metric conversions I do expect you to know. Only the metric to metric conversions use the base 10. If it's English to metric or within an American system, you got to know those numbers. And I'm not going to ask you to memorize any of them except the one I just put a star by. That 1 inch is equal to 2.54 centimeters. Now that you have found your conversion statement, or rather your equivalent statement, you now need to write down what is given to you in the problem. And in this problem, we have 2.85 centimeters. That's where we start. Then we're going to draw a horizontal line. Now draw a vertical line. A lot of students call this the T-chart thing. It's simply just dimensional, I'll try to say that again, dimensional analysis. And I'll show you what all these lines and stuff mean. The most important part of this is you do need to chase this unit down. You see this unit right here, this centimeters unit? Right there, centimeters. That's the unit we're going to be chasing down there. Watch. The reason we do that is because that will allow these units to cancel out. See, a centimeter divided by a centimeter is 1. It's the same thing as saying A divided by A, and that equals 1. This big horizontal bar, this horizontal bar is like a fraction bar. It represents division. This vertical bar, right there, that represents multiplication. It's just an easier way to write a bunch of fractions, and it keeps them all in line. Now that you've chased the unit down, you now want to write the unit you're trying to get to, which in this case is an inch. Now that you have that done, now all we have to do is stuff the numbers from our conversion ratio or our equivalent statement into the dimensional analysis. So the 1 comes down there and the 2.54 there. Now we're ready to simply do the math. This statement, by the way, is exactly the same thing as this statement. It's just a couple of fractions. And I don't think it looks as intimidating. Well, maybe once you get the hang of it, it doesn't look as intimidating. So what you need to do is remember that underneath this first number, 99% of the time, is simply going to be a 1. So we don't write it. We can ignore it, just like there's a 1 there. We don't really need that. Our centimeters have canceled. We're left with the unit we want. If you look at it over here on the grid that I drew, the centimeters cancel. We're left with the unit that we want, inches. Now, provided you can use your calculator correctly, the rest of this should just fall right into place. And you end up with this number. Does that mean we're done? No, it wouldn't be that easy. Remember, all measurements contain both a number and a unit. And the number has to pay attention to significant figures. Our initial measurement was 2.85. How many sig figs are there in 2.85? That is correct. There's 3 sig figs. So our answer should also have 3 sig figs. Recall, conversion units are exact numbers and we do not use them when dealing with significant figures. So we want to round this number to 3 sig figs, and I only care about those first 3. Now are we done? Nope, we still need our unit. Centimeters. Any questions? Make sure you jot those down. I have some more problems to practice with you coming up. Let's take a look at this problem. An Italian bicycle has its frame given as 62 centimeters. What is this in millimeters? Well, let's start off with what is given. 62 centimeters. And if you started off by writing down the equivalent statement, that's okay too. Now, centimeters appears up here, so you want to make sure that you chase this unit down. So centimeters goes here. And what are we converting it to? That's right, millimeters. Oh, snap, now we have to figure out the conversion. Because it's within the metric system, you can use that handy-dandy sentence from the previous video. King Henry died by drinking chocolate milk. And we are in this case going from milli to centi. Which one's bigger? The centimeter. So that one I'm going to put a number 1 next to. And how many millimeters are in a centimeter? Well, if you guessed 10 to the first, you would be spot on. So then your final answer comes out to be 620. Now let's make sure our units canceled. Yep. Is this the unit we wanted? Yes, it is. So we can write millimeters. And our last step, anyone? Yes, we have to check our significant figures. How many sig figs are there? 2 sig figs. So how many belong in our answer? 2 sig figs. And this number does have 2 significant figures because trailing zeros do not count unless there's a decimal point somewhere. Now, some of you are saying, hey, I remember doing this and I simply just wrote a couple of fractions, cross multiply and divide. You're right. For a one-step conversion, that will totally get you through. This is a process that I want you to learn. As we move forward in chemistry, this process is invaluable. Water is often bottled in 16-ounce containers. How many kiloliters would this equal? Well, on this problem, one of the things you need to know is that we are talking about a fluid ounce. And a fluid ounce refers to liquid. The other type of ounce we have refers to mass. But we're dealing with fluid ounces here. And the question is, how many kiloliters would this equal? Any conversion dealing with an ounce, I am so not going to ask for those. You can either Google it or I would give this type of information to you. In this type of problem, it's not quite does the trick, because if you notice, I am giving you fluid ounces over to milliliters, and yet the answer needs to be in kiloliters. And the point of this problem is that it involves more than one step in the conversion. And as these problems become more complicated, it is so much easier if you simply make a plan to begin with. So in this plan, I'm going to go from ounces to milliliters because that conversion is woohoo right there. But from milliliters to kiloliters, how are you going to do that? It's within the metric system, milliliters to kiloliters. So you should be able to go, King Henry died by drinking chocolate milk. If you can use that sentence like we did in the previous video, you should be good to go. Well, first step, let's write down what is given. 16 ounces. I'm going to skip fluid ounces. I know we're dealing with fluid ounces. So there's your division bar. I'm going to draw a multiplication bar. And if ounces is here, I need to chase that unit down. And according to this plan up here, I'm going to be converting from ounces to milliliters. And the conversion at the top says 1 milliliter has 0.03838. And that should be enough digits. Ounces, after all, we only have 2 sig figs in our number, so I don't need to get carried away on the conversion. This makes ounces cancel, which is exactly what we want. Ounces divided by ounces, good. That goes away. However, is the milliliter really the unit you want? No, it's not, which means I need another step, just like the plan said. So now you need to go from milliliters to kiloliters. Chase this unit down, milliliters, and we're going to convert that to kiloliters. Which unit's bigger, a kiloliter or a milliliter? Kiloliter, good. And the entire metric system is based on the power of 10, so we just need to figure out how many steps. So if we start here and we want to end here, let's see, that's 1, 2, 3, 4, 5, 6 steps. So it's 10. Where'd my pen go? Oh, there we go. 10 to the 6th. Please make sure when you enter this into your calculator, you're using your calculator correctly. I'm going to go ahead and jot it down for you, but you should have 16 divided by parentheses 0.0338 times 10 to the 6th. That's what you should be entering into your calculator. Oh, snap, I didn't cancel. Better cancel these out. Whoops. Is this the unit we're after? Yes, it is. Oh, good. So once you enter this into your handy-dandy calculators, then you should get 0.000473. That should be enough, right? Oh, 2 sig figs. Well, there's 2 ways you can write this. You can write it with all these leading zeros in it because leading zeros never count. 0.00047 kiloliters. Or you could have written it in scientific notation as 4.7 times 10 to the -4th kiloliters. And we are done with this problem. Try this problem on your own. I'm going to go ahead and solve it though. Okay, so we're looking at the length of a marathon race as 26.2 miles. What is the distance in meters? A conversion I don't expect you to know is that 1 mile is equal to 1.609 kilometers. Okay, well, we should be able to get to meters then, right? Because we're starting out with miles. So if I were to make a plan, I need miles to kilometers to meters. Okay, good deal. So let's start off with what's given. 26.2 miles. I'm going to draw this line thing. That's my fraction bar, now a multiplier bar. And you're going to take this miles and chase it down. Miles. And this plan says we can convert from miles to kilometers. And 1 mile is 1.609 kilometers. That makes the miles cancel out. Now we're going to take this kilometers or kilometers and chase it down here, kilometers, to meters. Well, let's see. That's the metric, meters and kilometers. So King Henry died by drinking chocolate milk. And where in this system are we? Well, the kilo most people don't have a problem with. Yeah, no problems. We're starting off here. But meters is not that one. Nope. It's one of the base units. It's one of the three: meters, liters, or grams. Grams. So we are going for the meters, one of the base units. Okay, which is bigger, a kilometer or a meter? Correct, a kilometer. So I'm going to put a 1 there. I lost my pen again. Yep, there it is. 1 kilometer. And 10 to the third meters. Punch it into your calculators and see what you get. When I punch all of this into the calculator, then I end up with, let's see, 42155.8. And yes, the kilometers canceled. Let's see if this number makes sense. Let's see, I have 26 times 1.5 times 1,000. Yeah, I can live with that. Okay, then we have meters as our final answer. Am I done? What? Well, if you said no, because Norton, you got to do sig figs, you'd be spot on. In this particular number, we have 3 sig figs. 26.2 has 3 sig figs, so we need to round this number to 3 sig figs. Go ahead and give it a try. So there's a couple of ways you can do it. 4, 2, well, I need these 3 digits, and the 5 says to do what to the 1? Round up to 0 meters. That works. Or you could have used scientific notation as 4.22 times 10 to the 4th meters. Either answer is acceptable. You just need 3 sig figs. This problem is the most difficult problem you will encounter in this chapter, or the most beautiful if you're looking at it from my geeky point of view. We're going to start off with 225 miles per hour, and we need to know what the speed is in meters per second. This is the part that's really difficult for students to grasp, but this number, 225 miles per hour, well, that number should be written like this: miles per hour. Because really, it's for every 225 miles in 1 hour. So when we start off with what's given, we don't just have a single unit on top. We have a unit on top and one on the bottom. Let's focus just on one of these at a time, and let's look at the miles. So how are we going to get from miles to meters? Well, pretty much like we did in the last problem. We're going to go from miles to kilometers to meters. See if you can pause the video and just do this problem. Well, I mean just this part of the problem. Okay. Well, I'm going to take miles and chase that unit down here, totally ignoring hours for now, completely. The plan says go from miles to kilometers. And let's see, 1 mile contains 1.609 kilometers. That makes my miles cancel. I'm going to chase this unit down here and go to meters. And from the previous problem, I know 1 kilometer has 10 to the 3rd meters. Okay, good. That got us the meters that we're after. Now I just need to figure out how to go from hours to seconds. Previously, I always said chase your unit down. Well, now we're going to chase it up because it started on the bottom. So now that I have hours down here, I'm going to change my pen color, might make it a little more clear. Now that I have hours down here, in order to get it to cancel, I need to put it up on top. So I'm going to put hours here. Let's see, hours to seconds. You might know the conversion, how many seconds are in an hour. And if you do, feel free to use it. I'm going to go from hours to minutes and then to seconds. And hours to minutes, let's see, lost my pen. Oh, there we go, to minutes. And I know that for 1 hour, I don't want to write that there. I know that for 1 hour, there's 60 minutes. And look, that's going to make my hours cancel. But I don't want minutes in my denominator. I want seconds in the denominator. So we're going to bring minutes up. We're going to chase this unit up and convert it to seconds. And I know 1 minute has 60 seconds. And that's going to make minutes cancel. And now let's see if at the end of all of this mess, we actually have the units we really want. Let's see, looking for units. Oh, there's a meters and it's in the numerator. Good. Seconds, and it's in the denominator because meters per second is really meters per second. Now, get out the handy dandy calculator and see what you come up with. Did you remember to put in the denominator all in parentheses? Because if you didn't, you're going to make a mistake. In this case, I have 100.5625 meters per second. Am I done? Oh, sig figs. Okay. All right, 225 miles per hour. I need 3 sig figs. And let's see, the 100 decimal, oh, the 5. Okay, yeah, see, I only care about these first 3 digits. The 5 says change the 0 to a 1, so I'm left with 101 meters per second. And we are done with number 13. Go ahead and try this problem on your own, and I'd like to see it tomorrow. As well as this one. Remember, there are 2 separate answers called for in this problem. Give this one a try. And yes, I want all 5 of these named. We cannot forget how to speak chemistry in. And there's your homework problems that we'll be working on in class tomorrow. Have a great night.